Today we are going to study screw gauge. So first I'll show you a sketch of the screw gauge, and I'll explain the different parts of the screw gauge. और उसके बाद हम एक सिमुलेशन यूज करेंगे, उसके वर्किंग को देखेंगे, how the screw gauge works. Okay, so first thing is this is a given sketch and a simple line sketch which tells us how the screw gauge looks like. And let's see what are this. So this is the U-shape main frame, something like this, where the different part of the screw gauge are attached. So this is the frame and on this frame, so this is a main structure which is holding all the parts together. Then this is known as stud, or it is also known as anvil, and it is a fixed surface. And what we do is we place an object against this surface. Then this is screw which is movable. It is also known as spindle. That advance this so this screw either advances or retracts when the this circular scale or this thimble is rotated. Okay. Then the main scale, where we can see the pitch scale, which is a cylindrical part, and this is a linear scale. This is known as sleeve. This is known as sleeve. We call it pitch scale, or we also call it as main scale. Okay. So what are the parts? The U frame, the stud against which the object is placed, the screw which can advance in the forward direction or retract in the backward direction. This is the pitch scale or the main scale or the sleeve, and we rotate this with the help of this thimble. A thimble also has this circular scale, which is also a rotating scale, which is also a rotating scale, and this gives us a finer reading. Gives us a finer reading. So we'll discuss this, and this is ratchet. So when we're rotating the screw, the purpose of the ratchet is that it prevents excessive force. It prevents excessive force or excessive pressure. What does this mean? That if you are rotating with the help of the ratchet, then as soon as the screw or the spindle gets touched with the object, and then again if you keep on rotating the ratchet, the screw will not move now. So it will only make 3 tick sounds, and when the screw gets in contact with the object and the object is firmly held within the stud in the screw, now even if you keep the ratchet rotating, the main scale will or the screw will not move in the forward direction, so it is not going to deform the object. That's the reason we should always avoid a screw gauge by rotating from the thimble. We should always rotate by rotating the ratchet. So this is the overview of the structure of the screw gauge. Now, why is screw gauge needed? So screw gauge is something similar to a vernier scale, which is used to measure the thickness of very small objects, or like the thickness of the sheet. So the screw gauge and the vernier scale which you use in your laboratory, the main difference I can see from the usage point of view is the least count of the vernier caliper is 0.1 mm, which we use in our laboratory, and for the screw gauge the least count is 0.01 mm. Okay, so it is more precise or more accurate in terms of the least count. That is the difference we can see between the screw gauge and the least count. So how do we use the screw gauge? So this is a working simulation of the, so I am rotating this with the help of the ratchet and not by rotating this circular thimble. Okay, even though in the animation I can use this thimble to rotate it because it stopped rotating, but when you are physically using the screw gauge, you should always rotate with the help of the ratchet so that it stops. Okay, first thing what we have to do is we have to close this spindle and it gets attached with the stud, and you have to see that the zero of the main scale, this line, coincides with the zero of the circular scale. If this happens, in this condition, we say that there is no zero error. So first thing what you have to check with the screw gauge is zero error. Exactly the same way what we did for the vernier caliper, we first identify the zero error. So here the zero error of the screw gauge is 0 in this position. Now I am just moving the ratchet here and you can see the main scale here. This portion is the main scale. Main scale also known as pitch scale. So this is 0 and the markings of the main scale are something like this. So this is one main scale division. It depends upon what the marking is, that this distance can be 1 mm also, or this distance can be 0.5 mm also. So what is the main scale division? It will be specified. When you look at it, the marking will be specified. So for example, in this figure, I have taken the main scale division as 1 mm. I can reduce it to 0.5 mm also, but that only comes from the reading, which is already marked there. You come to know that whether it's 0.5 mm or 1 mm. Now, this reading is on the circular scale. So on the circular scale also, the complete circle we may divide into. So if you see this circular scale is divided into 50 divisions. Okay. Uh, if the circle is bigger, you can also, so now if you see here, now this circular scale has 75 divisions. And this circular scale has 100 divisions. Okay. So again, different vernier screw gauges, screw gauge which you see in the market may have different. But generally, what we see is either the circular scale is divided into 50 parts or 100 parts. Okay. So the first thing is you close this screw gauge such that the stud is in contact with the spindle, or this anvil is in contact with the screw, and both the zeros coincide. So we are 100% sure that the zero error is, there is no zero error. Then we can open it, place the object between the stud and the screw, and then tight it so that the object is hold firmly between the stud and the screw, and then we can take our reading. So now if I want to see what is the reading here. So before taking the reading, the two terms which are defined for the screw gauge from the measurement point of view are pitch and least count. What is pitch? You may know that the definition of pitch comes from the definition of something from the screw. That is, if the screw is rotated by one full circular rotation, or in one full rotation, how much distance the screw, or in this case we'll say spindle, moves. Okay. So the distance moved to the spindle per complete rotation of the screw. And so if I see here, right now it's 0. Okay. Now I will make a one complete rotation. So I will make one rotation such that the 0 again comes back and coincide with this line. Okay. And now we see that the 0 coincides. So if I slightly go beyond, so I see that now this one, whatever is 1 here, my first line, it has moved this much of distance. Okay. And we know that right now we have said that the distance between the two divisions is 1 mm. That is what I have set up here. that the main scale division is 1 mm. That means for this setting, the pitch of the screw gauge is 1 mm. Okay, if I reduce my main scale division to 0.5 mm, that means now the pitch of this screw gauge is 0.5 mm. Or if I make this main scale division is 2 mm, main scale division is 2 mm, matlab the distance between this is 0 and the first line is 2 mm. Okay, so what we see here is, again the zeros are coinciding. If you again rotate it, and on one complete rotation, when both the zero is again coinciding with this line, this screw has moved a distance of 2 mm on the क्या बोलते हैं main scale. So then the pitch is 2 mm. Okay, so pitch is defined as the distance moved by the spindle per complete rotation of the screw. Then we define what is least count. So least count is defined as pitch divided by number of divisions on circular scale. Number of divisions on circular scale. So that is the definition of the least count. So for example, if I take my main scale division as 1 mm. Okay. So now if I rotate this screw, then how much has the screw advanced? It has advanced by a distance of 1 mm. And the number of divisions on this circular scale are 100. So 1 divided by 100 is 0.01 mm. That is the least count of this configuration of my screw gauge is 0.01 mm. What does this mean? This simply means that when I just rotate, see again here, as I rotate here, the zero has moved and the first division of the circular scale is dividing by the main line. So now the distance between these two stud and the screw is 0.01 mm. If I again rotate it, now the distance between the stud and the screw is 0.02 mm, 0.03 mm, 0.04 mm. So if the fifth division of the circular stud scale is coinciding with the zero line of the main scale, then the distance between them is 0.05 mm, because the least count of the scale is the screw gauge is 0.05 or 0.01 mm. Okay, so for example, let me open it arbitrarily like this. So if I want to see what is the reading or what is the distance between the stud and the screw at this position, then you can clearly see that 1 and 2. The reading 2 on the main scale corresponds to 2 mm because the main scale division of this screw gauge is 1 mm. So the main scale reading is right now 2 mm. And we clearly see that I am just doing zoom out for the clear visibility. We see that the 73rd division of the circular scale is dividing with the main line of the main scale. 73rd division, 74 and 75, 73rd division. Okay, so 73rd division, one complete circular scale is 0.01 mm. So 73rd division will correspond to the reading of 0.01 into 73 is 0.73. So this is our circular scale reading. So the total reading will be 2 plus 0.73 is equal to 2.73 mm. Okay. If I further rotate this, and if it just zero coincides that means we have reached the, okay. So now the 0 is coinciding. So now the reading is 1 mm, 2 mm and 3 mm. So the reading is 3 mm. So without zero error, you can always take the reading like this. Okay. So this much is clear how to take the reading from the screw gauge when there is no zero error. So without zero error, I can say without zero error, we can say the reading will be main scale division reading plus circular scale reading, that is least count multiplied by the division of the circular scale coinciding with the main scale 0. Coinciding with main scale line. Okay. So without zero error, this is a simple reading. Now let's come to the zero error part. Again, there are two types of zero error: positive zero error and negative zero error. So when is this zero error? The zero error means that the two zeros are not coinciding. So right now what I see is that both the zeros are coinciding. Okay. Now let me take the zero error as plus 5. What does this mean? That when my stud and the screw are touching each other, the screw gauge, the zero of the circular scale is not coinciding with the main line. So the screw gauge is saying, giving us some reading right now. So the reading of the scale right now is 5 into 0.01, which is 0.05 mm. So when actually the distance between the stud and the anvil or the stud and the screw is 0, the reading of the screw gauge is 0.05 mm. So this is known as positive error. This is known as positive error. And whatever reading we take with this positive zero error have to be subtracted from the reading. Okay. So now let me open this at any arbitrary position right now. So let us zoom again in to see what is the reading here. So what we see here now is the main scale reading is 1 to 2 mm and the circular reading is 89th division of the circular scale is coinciding with this line. So if we see the reading, the main scale division reading is 2 mm and on the circular scale what we see is that the 89th division is coinciding. 89th division. So the reading will correspond to 89 multiplied by 0.01, which is 0.89. So the total reading is 2 plus 0.89, which is 2.89. But remember, there was a zero error. When the screw gauge is supposed to read 0, it was not reading 0, it was reading 0.05. It was reading 0.05. So that 0.05 was a positive error which we have to subtract it. So the actual reading or the actual dimension will be, actual size will be total reading minus zero error, which is equal to 2.89 minus 0.05 and that is 2.84. So this is the correct answer. So the screw gauge reading right now is, the reading is 2.84 but the size of the object is 2.84 mm. Okay, is this clear? So this was positive zero error. Okay, now let's come back here and okay, now let me make the zero error negative, -5. Okay, now when I make the zero error -5, what is happening? If I do like this, what I see here is the screw gauge has advanced towards the left. The screw has advanced towards the left. It may happen when the surface of the stud and the surface of the screw may be क्या बोलते हैं, eroded. Okay. So what has happened is, now if you see here now uh, that the zeros are not coinciding, but what is happening is the 95th division, the 95th division of the circular scale. So how much distance it has moved in the backward direction? 1, 2, 3, 4, 5. 5 circular divisions, right? 95 is the fifth circular division from 0. From 0, first, second, third, fourth and fifth. So it is giving us a reading. So now suppose if I rotate this and if I coincide the 0 together now, then what we see here is when both the zeros are coinciding, there is a gap between the stud and the screw. When both the zeros are coinciding, there is a gap. So if I reduces this gap, then the 95 of the circular scale is coinciding with the main line of the main scale. So we say in this case, zero error is minus 0.05 mm. The zero error is now minus 0.05 mm. Okay. So what does this mean? That when both the zeros are coinciding, it is having some gap. Now let me open it arbitrarily, something like this. And if you see the reading, in this position, if you see the reading, sorry, I made a mistake. I was taking the zero error is -5. So let me make the zero error as -5. Perfect. And now take the reading. Now take the reading. So now my reading, if I see here, the main scale reading is 1, 2, 3. So the main scale division, if I take the reading, it is 3 mm. And if it's a circular scale division reading we see that this 54th division is coinciding with the main scale line, right? So that means the circular scale division is 54 into 0.01, which is 0.45 mm. So the total reading which we get now in this position is 3.3 plus 0.54, which is 3.54 mm. Okay. But remember, there's a zero error here. What happened actually was, when the two zeros are coinciding, there was some gap between the screw and the stud, right? There was some gap between the screw and the stud, and this gap was 0.05. Okay, so this much of it is reading 0.05 is 0. So this is a negative zero error, right? So what should be our actual reading? So the actual dimension will be 3.54 total reading minus zero error, and zero error is minus 0.05. So this will be 3.54 plus 0.05, and this will be 3.59 mm. So the actual dimension of the object will be 3.59 mm. I hope this is clear. So you've taken into consideration two zero errors. Either the zero error can be positive or the zero error can be negative. So the question which can come in your exam will be, either it gives us the position of the scale like this and ask us that we should calculate what is the zero error. So from this reading I can see that the zero error is -5, and from this reading you can see that the zero error is 5, and here you can clearly see that the zero error is 0. So either the question can give the figure where the lines are coinciding and ask you to figure out what the zero error is, or it may explicitly write the zero error in the question, that 0 is plus 0.05 mm or minus 0.05 mm, or it may write in the language that the fifth circular scale division is coinciding with the main line, or the 95th circular scale division is coinciding with the main line, which will tell you whether the zero error is positive or negative. So once you have identified what is the zero error, you have to subtract the zero error from the reading, and the zero error itself has a sign, positive or negative. So here the zero error is positive, so it will be 2.89 minus 0.05, and here the zero error was negative, so finally it becomes 3.54 minus of 0.05, so it becomes 3.54 plus 0.05, 3.59. Okay, so the question can come in any way. It may give the figure and ask you to find out whether the zero error, what is the zero error, positive, negative, or it may actually give you the value of the zero error, or it may ask you to imagine that these lines are coinciding, so find out the zero. The another thing which the question can give is, instead of giving zero error, the question can give us zero correction. And remember, correction is always negative of error. So if the zero error is plus 0.05, then the zero correction in this case will be minus 0.05. Okay, and actual size will be total reading minus zero error, which will be replaced by now plus zero correction. So if the zero error is plus 0.05, then the zero correction will be minus 0.05. Okay, now minus 0.05. So that is the difference. Okay, similarly in the second case which we did, here the zero error was 0.05 minus 0.05, negative zero error. So the zero correction will become positive. Zero correction will become positive, and zero correction will be plus 0.05. So actual dimension is equal to total reading plus zero correction. So it will be 3.54 plus 0.05, which is 3.59. So be careful whether the question is giving zero error or zero correction. Depending on that, you will use actual reading or total reading plus minus zero error, total reading plus zero correction. Okay, so I hope this is clear. Anyone who wants to do JEE coaching for main or NEET or JEE advanced can always contact me on my number. My number is written below, and you can also contact me on 9001-784-209. I have done my B.Tech from IIT Bombay, and we have both online classes for JEE Main, JEE Advanced, NEET, and we also have online classes and offline classes for math Olympiad exams, as well as uh, a very powerful course of teaching math, which will remove the phobia of the students, which will fall them in love with mathematics. So for any inquiry, you can always reach me out on this number 9001-784-209.